Okay, let's get right into it. We've all heard about AI that can sniff out fraud, right? But what if you had a system that doesn't just find it, but actually stops to explain exactly what it found and why it's so suspicious, all in the blink of an eye? Well, that's what we're breaking down today.
And here it is in action. This isn't some theoretical model, it's a live dashboard, and transactions are just flying by, 50 every single second. But look over on the left, boom, one gets flagged with a 98.5% fraud score. And instantly on the right, a full detailed AI agent report pops up. There's zero delay. It's detection and explanation happening at the exact same time.
Which, brings us to the core problem here. Usually, you have to pick one. You either get a black box model that's super accurate but can't tell you how it thinks, or you get a simpler one that's easy to understand but way less powerful. So the real question is, how do you build an AI that's both a genius predictor and a fantastic communicator? Well, the answer is you stop thinking about a single monolithic AI. Instead, you build a team. In this case, it's a multi-agent system that works just like a digital forensics team, where every single agent is a specialist with a very specific job to do.
So let's meet the team. First up, you've got the detective. That's your prediction agent. Its only job is to sift through a mountain of transactions and raise a flag on anything that looks off. Next, the squad leader, or the triage agent, steps in. It looks at the detective's finding, immediately sizes up the threat, and recommends what to do. And finally, you have the analyst, the explanation agent. This one takes all that technical jargon and writes a clean, simple report that any human can instantly understand and act on.
This diagram really lays out the whole process beautifully. A transaction comes in at the top. Agent 1 gives it a probability score. Agent 2 applies some business logic and says, here's what we should do. And then Agent 3 writes up the story. So the final output isn't just some random number. It's a full-blown actionable fraud report with a risk level, a confidence score, and a plain English explanation of what's going on.
All right, time to pop the hood and see how these agents actually work, because this is where the really smart engineering choices come into play. So Agent 1, our detective, is built around a super high-performance XGBoost model. It takes in all the raw numerical data from a transaction, the amount, the time, other anonymous features, and its entire job is to spit out one single number, a score from 0 to 1, that says, here's how likely it is that this is fraud. That's it. It's a pure prediction machine.
Now, a score like, say, 0.9874 is great for a data scientist, but it's not really an action plan. That's where Agent 2, the triage agent, comes in. Think of it as a translator. It takes that raw score and applies some really simple but powerful business logic. If a score is over 95%, bam, that's extremely high risk, and the recommendation, block immediately. It turns a statistic into a direct business command.
So at this point, our first two agents have found a high-risk transaction and they've recommended blocking it. Awesome. But a human analyst is still sitting there asking, why? They're staring at data that looks like this: XGBoost scores, risk levels. It's powerful stuff, but it's not exactly telling a story. So how do you bridge that gap?
You bridge it with this. Instead of just getting a bunch of numbers, the system gives you a narrative. It doesn't just say a feature is unusual. It tells you what it means. Here, it spots that a teeny tiny purchase of 89 cents, plus some other weird data points, is a classic sign of a fraudster testing a stolen card to see if it works before they go make a huge purchase. Now, that is the difference between data and real intelligence.
And that amazing clarity comes from Agent 3. It's powered by a whole suite of Google's Gemini large language models. It takes all the technical stuff from the first two agents and just synthesizes it into that clear, structured report. The design is also incredibly robust. It usually uses the fastest model Gemini 2.5 Flash, but if there's ever a hiccup, it automatically fails over to two other backup models. This whole setup ensures the explanation system is basically always on.
But to get those predictions in the first place, the model had to be tuned perfectly. And the absolute most critical piece of the puzzle is this last parameter, scale_pause weight. See, in this data, fraud is super rare. For every one fraudulent transaction, there are 173 legit ones. This one parameter tells the model to pay 173 times more attention when it sees a fraudulent example. Without this, the model would just get lazy and predict not fraud every time, which would make it totally useless. This is the secret sauce for finding that needle in a haystack.
Okay, so we've got a smart architecture, we've got a finely tuned model, but the big question is, does it actually work? Let's get to the results and see how the system really performs when the pressure's on.
This is the number that says it all.
0.9886. That's the test AUC score. It's a key metric that basically measures how well a model can tell the difference between two things. In our case, a fraudulent transaction versus a normal one. A perfect score is 1.0, and a 0.5 is just random guessing. So yeah, 0.9886, that is exceptionally good. Let's break that down a bit. That test AUC of 0.9886, that confirms this is elite tier performance. But what's almost as important is the overfitting gap. The model scored a perfect 1.0 on the data it trained on and 0.9886 on data it's never seen. That tiny gap of just 0.0114 means the model didn't just memorize the answers, it can actually generalize to new situations. It proves it can handle that crazy 173-to-1 imbalance and is absolutely ready for the real world. And just to put that 0.9886 score into perspective, the industry standard for a production-ready model is generally a score of 0.98. So this system clears that bar with room to spare. In fact, this result is right on par with what you see in published academic papers that use this exact same dataset. What this means in plain English is that the system correctly flags nearly 99% of all actual fraud cases. It's just incredibly effective.
But really, this project is about so much more than just a high-scoring model. What we have here is a complete, production-ready blueprint.
And you can see that in its design. The whole separation of concerns idea means each agent has one job, which makes the whole thing easy to maintain. It's modular, so you can swap out the prediction model for a better one later without breaking the explanation agent. You've got that explainability built right in from the start, a robust failover system for reliability. It's just a solid blueprint for how to build AI systems you can actually trust.
What this really proves is that the future of complex AI might not be some single, all-knowing oracle. It might just be a well-organized team of specialists. And that leaves us with a fascinating question. If an AI detective squad can solve fraud, what other complex, unexplainable problem are they going to tackle next?